So, those who attended like 2 days back the demonstration, they don't need to attend it because same thing is going to be repeated. So there is no like, yeah, if you still want to attend, then you can attend. There is no problem in that. So the topic again will be maximum likelihood estimate. I have taught it earlier also 2 days before. So I will be teaching same topic. This demo class is especially for them who were not able to attend that day. So starting, before starting, I will like to clear something. The classes one second, let me. Okay. So, before starting, the classes is going to happen on Saturday, Sunday, 6 to 9 in evening. Okay, that demo class has happened on Friday, but the classes is going to be always on Saturday and Sunday, 6 to 9. And the medium of the class will be English. The medium of the class will be English. Demo class notes, whatever I'm going to write on this my iPad, I will be sharing with all of you like after the class only. Okay. So, suppose I'm teaching something. So the notes, usually, Saturday, Sunday notes I compile and, I provide it on after the class on Sunday. So you can, you get a time of 5 days to revise notes. Okay. But, I will like, you have to make your own notes also. So topic is MLE. Okay. So in MLE, what we do, before, like, the name itself, is suggesting something that what is MLE? MLE is basically maximum likelihood estimate. And what is that? We are, from name itself, you will get some idea that we are maximizing likelihood. Okay, we are maximizing likelihood. Now, what is likelihood? We denote this by L. So L is what? L you have usually studied as product of f of xi comma theta. And theta belongs to whole parameter space. It is I equal to 1 to n. If x1, x2, xn are n independently identically distributed random variable. Okay. If it is not, then also we can, like, if it is independent only, then also we can multiply this way. Now, what is likelihood function? So about likelihood function, I can say that it is a function basically. See, in likelihood function, it is function of parameter. Okay. So if you are going to see likelihood function and joint probability distribution. So likelihood function, joint probability distribution. See if x1, x2, xn are NIID and independently identically distributed random variable. So for joint probability also we are going to take product of this, and for likelihood also we are taking product. So what is the difference? So that difference, all of you write in your chat box, like what is difference between likelihood function and joint probability distribution? All of you respond in chat box. Yeah, please speak louder. Yes, I am asking that. कि what is difference between likelihood function and joint probability distribution. Okay, is my voice now, is it okay? Now am I audible more?
Yes, yes.
Okay, okay. Yeah, likelihood is for independent random way. See, so somebody has written that key likelihood is function of parameter given random variable values. It is very correct. Whereas joint probability distribution is function of random variables, and your theta is considered at some fixed value, some fixed unknown value. So in both cases, what is difference is for likelihood function, what we say, function of theta, where x1, x2, xn are already given. Okay, this is a observed sample. You all must have done questions like x1 equal to 0, x2 equal to 3, x3 equal to this way they have given values, and they will be asking likelihood function of some theta. You must have seen that type of question. Otherwise, we are going to see it in upcoming time. But so there already x1, x2, xn are given in this case. And in joint probability distribution, what happens? It is function of x1, x2, xn, where theta is given. This is the difference between joint PDF and likelihood function. Now what we do in MLE, as theta is a random variable here, as theta is a random variable here, we will try to maximize L with respect to theta. Now one more question comes to our mind. How we are going to maximize our L? So there is a mathematical rule, or you all have studied differential calculus. In that, what we say, if we have to find maxima of f of x, so what we do, we just take differentiation of f of x with respect to dx equal to 0. This should be happening, and d square fx, this should be less than 0. This is basically the condition for maxima of fx. Okay, so now here what we want to find, is maxima of L. Okay, so maxima of L, how to find? dl by d theta should be equal to 0. Here what happens is we want to find maxima of fx with respect to x. Here we want to find maxima of L with respect to theta. Here your y equal to f of x. This way something is there. Here L is equal to f of theta. So you can see, so now dl by d theta equal to 0, and d square L upon d theta square should be less than 0. This should be the condition. Now before this was the they used to do it like this way. But after differentiating L with respect to theta in exponential families and all, it became quite tough and calculative to find dl by d theta. So what they came up with a solution. What solution was that? We are going to, instead of finding maxima of L, we are going to find maxima of log L. Instead of finding maxima of L, we are going to find maxima of log L. Now, why we are going to find maxima of log L? Because Suppose at theta equal to 2, L theta equal to 5. At theta equal to 3, L theta equal to 7. At theta equal to 5, L theta equal to 1. Okay, at theta equal to 2, L theta equal to 5, theta equal to 3, L theta equal to 7, theta equal to 5, L theta equal to 1. Now all of you tell me, what is going to be the MLE of theta in this case? You are given this example, okay? MLE of theta. All of you write in the chat box. Okay, so somebody, three or four of you answered theta equal to 3. Now, anybody of you write the reason why theta equal to 3 is the MLE. Now from here, what we want? We want maximum of L of theta with respect to theta. Maximum of L of theta with respect to theta. Now maximum L theta is what? 1 is less than 5 is less than 7. Therefore, maximum of L theta is what? It is 7. And at which theta it is occurring? At theta equal to 3. Therefore, we can write that theta equal to 3 is the MLE. Okay, theta equal to 3 is the MLE. Now coming on to next question, why log? You can see that L theta's value is 5, 7, 1. Log L value will be log 5, log 7, log 1. Okay. Now all of you answer that log 5, you have to know that log L is log X is increasing function of X. Log X is increasing function of X. Okay. So if log X is increasing function of X, we know that if 1 is less than 5 is less than 7, it will imply that log 1 is less than, log 5 is less than log 7. Okay. Therefore, log L theta is maximum at log 7. It is also going to be happen at theta equal to 3 only. We can write the value of theta here. Theta equal to 2, 3, 5. Theta 2, 3, 5. So again, we can see that log 7 is the greatest among all three values. Therefore, theta equal to 3 is again coming as MLE. Therefore, log L is maximum at theta equal to 3 with log 7 being greater than log 5 being greater than log 1. So, that's why we maximize, because log X is increasing function of X. So we can write log L is increasing function of L. So, wherever we are going to maximize L, at the same theta, log L will also be maximized. So instead of differentiating L, instead of finding maxima of L, we find maxima of log L. Why log L? Because differentiating log L is easy. Differentiating log L is easy. So until here, those who understood, please type yes in the chat box. Those who are not getting, please type no in the chat box. Please, especially those who are not getting, Please type no in the chat box. Okay. So now you all know that we have to maximize likelihood function, and at whatever theta we can maximize likelihood function, that theta will be the MLE. And then next thing what we learned today is instead of maximizing log L, we will maximizing L, we will try to maximize log L. So that we learned today until now. Now coming on to some questions we are going to do, and see, properties of MLEs will be discussed after. Okay, so let's start with some question. Yeah, one question is this: fx is equal to half exponential minus x minus theta. Okay, minus infinity to infinity, x belongs to theta belongs to minus infinity to infinity. Okay, x1, x2, xn are IIDs. x1, x2, xn b IIDs. Okay. So first thing, what we are told to do. This is a bit tough question. It is not an easy question. So now do one thing. We will be keep this question aside. We are not going to do right now this one. We are going to do some easy question. After that, we are going to come to this question. We have to find, the question is we have to find MLE of theta. Now coming to next question. This is a bit difficult. So, we are going to do it after doing 3-4 questions. Question 2. P of x is equal to theta raised to x, 1 minus theta raised to 1 minus x, x is equal to 0, 1. Okay. And theta is lying from 0 to theta to 1. Find MLE of theta. Okay, and x1, x2, xn are independently, identically distributed random variables. And P of x of I you can take. So all of you just do in your notebook and tell me the answer, then I will do it here. Just write the answer in the chat box. Anybody, what is the answer? This is quite easy question. So I think many of you must be knowing the answer. Okay, mean. Okay. Sigma xi by n. Okay, so it is easy question. Let me do it. So now you should know this procedure. So first what we are going to find, likelihood function. Okay, so this is going to be product of xi I equal to 1 to n. So this will be product of I equal to 1 to n theta raised to xi 1 minus theta raised to 1 minus xi. So this is going to be theta raised to summation xi 1 minus theta raised to n minus summation xi. This is value of L, and we know that now you can see what I was saying. If you have to differentiate L with respect to theta, it will become difficult for you. Okay, it will become difficult for you. So what we like differentiating this expression with respect to x will be a difficult task. Okay, so what we are going to do, theta. So we are going to take log L. Log L will be equal to summation xi log theta plus n minus summation xi log 1 minus theta. Log L, del log L upon del theta, this will be equal to summation xi upon theta plus n minus summation xi upon 1 minus theta with a -1 sign here. Okay, so you will solve it and you will get it theta equal to x bar. This is very easy calculations. So now, now this is one question. Okay, so second question is, suppose x1, x2, xn follows Poisson lambda. Okay, x1, x2, xn are IIDs, they are following Poisson lambda. Find MLE of lambda. This is the question. So how to solve it? Again, you can do one thing. You can take L. This will be equal to product of P of xi, product of e raised to minus lambda, lambda raised to xi upon xi factorial, I equal to 1 to n. This is going to be equal to e raised to minus n lambda, lambda raised to summation xi upon product of xi factorial. This is equal to L. Log L will be equal to minus n lambda plus summation xi log of lambda minus log of product of xi factorial. Del log L upon del lambda will be equal to minus n plus summation xi upon lambda minus 0. So it will imply that lambda will be equal to x bar. So this is very easy question. Okay. Now, you can, like there are multiple questions. I want this, all of this to solve on your own. X1, X2, Xn, assume, X1, X2, Xn are IIDs. Xi is following normal mu comma sigma square. First case is find MLE of mu. Sigma square is known. Okay. So you have to, this is first question of third. Basically A part. B part is find MLE of sigma square. Mu is known. And third question is find MLE of mu and sigma square. Simultaneously they are not known. So it is a very easy question. What you have to do, again you have to find L, likelihood function. Then you can take log of that likelihood function, and then you can differentiate with respect to mu and sigma square, and you can find the answer. So all of you want me to solve it, or all of you can solve it on your own? So we can do some better question, because this is a typical MLE question. So those who want me to solve, type no in the chat box. Those who want to solve on their own, please type yes in the chat box. Respond fast, because be very attentive in my class. Be very attentive and respond very fast. Okay. Okay, so those who want to solve on their own, type yes in the chat box. Those who want me to solve, okay, I can solve by own, yes. Okay. So I think maximum of you can solve one. Okay. So okay, C is something. Satya Sai is saying that C no and Nisha no. Okay. See, I'm again, I'm saying again, repeating same thing. Do one thing, take likelihood function. So L will be equal to 1 upon root 2 pi sigma square raised to n exponential minus half summation xi minus mu the whole square upon sigma square. Log L will be equal to minus n by 2 log of 2 pi minus n by 2 log of sigma square minus half summation xi minus mu the whole square upon sigma square. Okay. Del log L upon del mu equal to 0 implies 0 minus 0. So you will easily get minus half summation xi minus mu. So 2 will be here plus 2 upon sigma square. This equal to 0 will imply mu equal to x bar. So this way, you can do. Then second thing, del log L upon del sigma square. Here you take sigma square is unknown. First case I solved. Then second case, B part, del log L upon del sigma square equal to 0 implies this will be equal to what? Minus n by 2 sigma square plus 1 upon 2 sigma raised to 4 summation xi minus mu the whole square. So now solving you will get sigma square equal to summation xi minus mu the whole square upon n. Okay. Here in B part it is unknown. So in C part what will become? You will again get mu equal to x bar, same as first way. And for when you will del log L upon del sigma square, you will get sigma square equal to summation xi minus mu the whole square upon n. But sigma square is mu is unknown here. Mu is unknown here. So what we can do? We will put instead of mu MLE of this mu xi minus x bar the whole square upon n. See, this is quite famous question. That's why I am not telling you in much detail. But still, if anybody of you have doubt, write no in the chat box. If you understood, then it's okay. Then type yes. See, this is very easy question. Same way you have to find likelihood function. In C part, what you have to do is in C part, when you will differentiate log L with respect to mu, you will get mu equal to x bar, and that same x bar you have to use while estimating sigma square. Okay. So this, this is case for normal one. Then, coming back to that question, that first question. That question what I left, x1, x2, xn are IID, identically independently distributed random variables. We are going to discuss this what is this IID in random variable chapter. Okay. Fx is equal to half exponential minus x minus theta. Your x is lying from infinity to infinity, your theta is lying from infinity to infinity. Find MLE of theta. Before starting this question, we need to discuss some detail. Okay, so what that details are? I have to ask all of you one question. Ki summation xi minus may is minimum when a equal to question mark. And second question is summation xi minus a the whole square is minimum when a equal to what? So this is basically it's a part, this is basically B part. Those who know the answer, these are quite popular results. This you all should know. So, those who know the answer, please type answer in the chat box, for A also and for B also. So somebody typed, A equal to median and B equal to mean. Okay. First case median and second case mean. So now all of you are knowing this, like some of you are knowing this. So that means that this is a popular question. This you all should know. So the question what I have done till now for Poisson, for binomial, for normal, it is not going to come in a very it is not a very tricky question. But the question that I'm doing right now, this can come into the examination. So you should know that the direct question, you don't expect direct question in the examination. If it comes, take it as something. See, if suppose there is one direct question, So, everybody is going to attempt it and everybody is going to score marks. So, that is not going to be very helpful for you because, you are also doing, everybody else is doing. So, everybody is getting mark. Exam is always about relative things. So, if some question is tricky and, you are able to do it and others are not able to do it, then, then you will be going ahead of them. So, first case, this is very popular result. So, A will be, when A will be median. And in this case, when A will be mean. Now, we all know that another thing, differentiating mod x with respect to dx, this comes as mod x, x inverse, x should not be equal to 0. X should not be equal to 0. Okay. X should not be equal to 0. Now, we are given fx is equal to exponential minus mod of xi minus theta. Okay. Half is there. Now, likelihood function will become multiplying, product of f of xi. So that will become half raised to an exponential minus summation mod of xi minus theta. Okay. Log L will become minus n log 2 minus summation mod of xi minus theta. This becomes log L. Then del log L upon del theta. This will become 0. And this will become what? Suppose take t equal to xi minus theta. Take t equal to xi minus theta. So this will become equal to 0. This will become summation signum function t. Okay. Minus sign will be like, see what will become. What is signum? This minus sign will, because we are xi minus theta, then one minus will be coming. So this minus will be gone. Now what is signum t? This will be equal to 0. T less than 0 equal to equal to minus 1, equal to 0, t equal to 0, equal to 1, t greater than 0. But t cannot be equal to 0 here. Why? Because due to this. Okay. So this cannot be equal to 0. See, even though we will be putting this equal to 0, even though we are putting this equal to 0, we are not getting any answer. Suppose we are taking that key del log L upon del theta equal to summation signum function xi minus theta. Okay. And xi can't be equal to theta because it cannot be equal to 0, something like that. So, this will become, if we are putting this equal to 0, then, we cannot do this, because x1 minus theta, x2 minus signum, sir, xi cannot be equal to theta. So, this answer cannot be, we cannot get any answer because this differentiation will be coming as this only when xi should not be equal to 0. And we want it to be equal to xi minus theta equal to 0. We want this to happen. This is only going to happen when xi is equal to theta. That means no value for theta we are getting. This is not a single question. This is not a single question where, after differentiating also we are not able to get any answer. Everybody please mute your audio. So, no value of theta, see, so this is another type, first type is what? if we were finding likelihood function, then we are finding log likelihood function, we were differentiating and we are getting the answer. But now there is a question, where after differentiating log L, we are not getting any value of theta. So, after differentiating, we are not getting maxima. Basically, what we wanted to find, what we wanted to maximize likelihood, here we cannot maximize it. So now what to do? What we can do? Log L, suppose L is equal to what? 1 upon 2 raised to n exponential minus summation mod of xi minus theta. Okay. This is your L, and our job was to do what? Our job was to maximize L. To maximize L, we have to maximize this entire quantity. Okay. So, this is a positive quantity. So we can write, we have to maximize as this entire this is a positive quantity, so we can remove it. Okay, this is a fixed quantity, so we can, this is a constant term. So now we have to maximize this. Okay, now as this is in exponential term, so minus summation mod of xi minus theta we should maximize. Then as there is a negative sign, so I can write that summation xi minus theta should be minimized. And we know that this is going to be minimized as theta equal to median. So those who, again I'm repeating, see, if we are not getting MLE of theta by differentiating log L, then we have alternative method. That alternative method is what? We have to maximize L. Directly we are going to find such value of theta. How we are going to find? We are going to use either order statistics or something like this. So we have to maximize L. So entire expression needed to be maximized. Then this is a constant term, so we can remove. So this term should be maximized. Okay, now e raised to. So the power, e raised to, suppose 2, e raised to 3, e raised to 4. So that power should be maximum to for e raised to something to be maximum. So this power should be maximized. Now there is negative sign. So we know that -1 is greater than -2, therefore this should be minimized. So theta will be equal to median. So now those who understood this problem, please type yes in the chat box. Those who are not getting it, please type no in the chat box. So if anybody of you are not getting it, don't be shy or something like that. Yeah, understood the last concept, but not the signum part. Okay. Yeah, sure. Can you explain the last line? So, so I will start with the signum thing. Okay. So log L is equal to what? Log L was equal to minus n log 2 minus summation mod of xi minus theta. Okay. Now del log L upon del theta will be equal to 0 minus summation xi minus theta mod into xi minus theta this way. Okay, this is mod, this is xi minus theta normal, plus sign will be there. So we can write summation mod of xi minus theta xi minus theta. Okay, now I can write this is going to be equal to 1 xi less than theta. So this is going to be what? Minus xi minus theta minus 1 into 1. So it will be -1. Okay, those it will be minus n, and xi greater than theta, it will be n. So after differentiating, are we able to find any value of theta? Suppose you are differentiating this. So even though if you differentiate this, I'm not writing any signum thing. I'm just writing this way. So even though you are like doing this, you will differentiate this. You are put it equal to 0. You are not getting any value of theta. You are not getting anything for theta by differentiating it. This is not a single problem. There will be multiple problems where you will differentiate log L, where you will differentiate L, and put it equal to 0, and you won't get any value of theta. Okay. So in that case, what we do this way. We maximize L directly. So to maximize L, this is entire expression of L. This is entire expression of L. Then we want to maximize this entire thing. So to maximize, this is a constant term, so we can remove it. We have to maximize this thing, second term. Then to maximize second term, we need to maximize its power. So we maximize its power. Now the power has a sign minus thing. So to remove minus, this should be minimum. If we want this to maximum, why this? Because we know that E square, E cube this way, E4, E5. Now suppose E raised to -2, -3, -4, -5. So the bigger with minus sign, it is going to be lesser. So now that's why we want it to be minimum. So that's why now I used one result. This should be minimum. This minimum happens when theta is a median. Now all of you, please, those who were like typing, they're not understanding, please type, whether you understood or not. Kingsuk, Jana and HM. Okay. Kingsuk, Jana. Okay. Then moving forward, so we have see, this is basically seen. So one more thing I want to tell all of you is that if you get a question in the examination, that won't be a random question. In every question, examiner want to check whether you are understanding a particular concept or not. Okay. Suppose there is something like limit and limit probability. It will be central limit theorem. It is a direct question. In JAM, it comes every year. In ISS also, they ask this question. So the moment you solve limit and probability, that will be a question of central limit theorem. If you are getting something like expectation of x1 given summation xi, that something like that, understand that application of Rao-Blackwell theorem will be there. Okay, so this way, in like if you are asked MLE question, maximum likelihood estimation question, understand that they want to check the knowledge of every type. Like suppose question comes like that. Type 1 is what? Type 1 is basically where you are differentiating L or log L and you are getting directly the answer. That is type 1. If you are not able to get that after differentiating, and you are using order statistics or how I have solved that way, then that will be called as type 2. So they will be checking every type of question to you. So now fifth question, fx is equal to okay. So this is basically gamma. According to Gupta-Kapoor, if you are considering, so it will be b equal to 1 by theta, a equal to 3. So this is PDF. You can rearrange because there are multiple notations of gamma distribution everywhere. So now you have to find MLE of theta. Use del log L upon del theta equal to 0. You will get answer. Very easy question. Just you need to find L, then log L, then differentiate, then you will get the answer. This is basically question of type 1. Okay. Sixth question. Fx is equal to theta x raised to theta minus 1. X is lying from 0 to 1. Theta is lying from 0 to infinity. You have to find MLE of theta. This is also part. This is also a type of. This is also same as type 1 question. So we will do this. So L will be equal to theta raised to n product of xi theta minus 1. Okay. So log L will be equal to n log theta plus theta minus 1 log of product of xi. Del log L upon del theta will be equal to n upon theta plus log of product of xi. Okay. So del log L upon del theta equal to 0 implies n by theta equal to minus summation log xi. Log of product of xi can be written as summation log xi. So theta will be equal to n upon minus summation log xi. So this is also type 1 question. Easily it can be done. Now there is one question. Fx is equal to exponential minus xi minus theta. Xi is equal to, and xi should be greater than theta. So, in this question, it becomes bit tricky. Why bit tricky? Because we are seeing it for first time that our range of x is depending on theta. Our range of x is depending on theta. So, what we have to do is, we have to, take L, then log L, then we have to differentiate it with respect to theta, and we have to see that whether we are getting any MLE of theta and all. So, then you have to take intersection term. See, there is one condition on xi, theta. Theta should be less than xi. So, can I write this way? Theta should be less than x order 1, x order 2, x order n, where x order 1, x order 2, x order n are order statistics. Order statistics and this PDF and everything, will be taught in the continuous random variable, distribution. So now how I am going to teach, I am going to start with probability and random variable. Why I am teaching MLE right now? Because, I think, theory of MLE is very less. So, in demo class, I usually teach MLE because, there is very less theory, like two pages theory, so that I teach and I can solve some questions. So you will get idea like what type of question and what difficulty level question we solve in class. Okay. So that's why I teach MLE. Now, x order 1, x order 2, x order n are order statistics. Xi should be greater than theta. Now what we can do? Find L. Exponential minus summation xi plus n theta. Log L minus summation xi plus n theta. Del log L upon del theta will be equal to 0 plus n, and this is equal to n. So, putting del log L upon del theta equal to 0, we are not getting any value of theta. Okay, we are getting nothing. So now what we can do, we have to, see if we would have got some value of theta. So, one value this would have been, and second one, this property, this should be satisfied because xi should be greater than theta. But in this case, we are not getting any value of theta. So we can write theta should be less than, this should be satisfied, and we have to maximize L. So maximizing L will be how? Exponential minus summation xi plus n theta. Okay, this should be maximized. So we can write now, exponential minus summation xi we cannot do. This is a positive quantity. So now maximizing this, we have to maximize this. Then we can write this is a basically observed sample. So this is exponential raised to anything will be always a positive quantity. So exponential n theta. So this will imply that n theta should be maximized. This will imply that theta should take its maximum value. So theta, theta is always less than x order 1. So maximum value of theta is x order 1. Therefore, this will be the MLE. And say, I have explained, many things that you should take intersection and all. That is very rare thing. That is very rare thing. In 90% of the cases, what you have to do, if the range of x is depending on theta, what you have to do is, you just write, this way, theta, x order 1, x order 2, x order n. Suppose, theta is less than xi, so we can write this way. So in this case, x order 1 will be the MLE. And suppose, this is this way, ki theta, xi is, suppose for some other question, not for this question, some other question. Xi should be less than theta. So in this case, what we are writing, x order 1, x order 2, x order n, this should be less than theta. What is x order 1, x order 2, x order 3? This is basically order statistics. That means that whatever is greatest, we are like x order 1, we have arranged the observed sample in ascending order. Okay. So in this case, x order n will be the MLE. See, so till here we solved that question, and I am talking about some other case. Some other case where your xi is less than theta, where your xi is depending on theta in this manner for some other PDF. This question has been solved till now, till here only. I have started something like, I am taking just one example. Suppose the range of xi is, that xi should be less than theta. So in that case, x order n will be the MLE. So those who have got this question and the given some other case, please type yes in the chat box. Those who are not getting, please type no in the chat box. Okay. So somebody told, can you explain this question once again? Order statistics 1. So can you please unmute your audio and you understood, or should I explain it again?
If you can just explain the portion where you started deriving the theta cap for it, like the process of it.
This one?
Yeah,
from
from
here?
L equals to exponential minus summation x by plus n theta from there.
Yes. See, what I have done is, I took likelihood function I found, then I took likelihood of it, log likelihood, then, I differentiated, and, I got n as answer. Okay. Hello?
Yeah, got it.
Yeah, n as answer, then, I differentiated with respect to theta, and I'm not getting any value of theta here.
Correct.
Not getting any value.
Okay, that's cross.
Okay. See, in maximum cases, in 90-95% cases where your range of x is depending on theta, you won't be getting any answer. Okay. But, I'm not telling that in 100% cases, because in some cases where your x is depending on theta, and you will get after differentiating, you will get an answer. So in that case, you need to understand that MLE of theta and whatever restriction you have. Here restriction is what? Your theta should be less than xi. So, your x order 1 should be greater than theta. Now, what I have done? I have just, like previous example, I tried to maximize L. So, again, exponential, this thing should be maximized, this should be multiplied. This is a positive quantity. So, exponential n theta. Okay, this way. So, you understood after this?
Yeah.
Okay.
Just one thing, like you mentioned, in some cases where we'll be able to find out after differentiating, and suppose there is a condition of order statistics as well. How do we find a solution by combining both of them in the question?
Suppose you are getting theta equal to
X bar. That's right.
X bar. Okay. And your theta should be greater than x order 1.
Correct.
So your x bar should be greater than x order 1. So what you are going to take theta equal to x bar, when your x bar should be greater than x order 1. Okay, equal to x order 1 when x bar is less than x order 1.
Understood.
Again, she asked a very good question. Suppose, after differentiation, this is some other case. This is just an assumption. This is just an assumption. Suppose, in this case, what she is saying that, suppose, we differentiated log L with respect to theta and put it equal to 0, and we got theta equal to x bar as this answer. And, your range of x, in question, what it is given, ki xi should be less than theta. Sorry. Take it as here it is given xi should be greater than theta. Okay. Suppose this is this way. Xi this is condition. Suppose, in the previous question, what is there? Suppose after differentiating, we are getting theta equal to x bar. Okay. But restriction is that xi should be greater than theta. What does this mean? Theta should be less than x order 1. This way, order statistic we can write x order n. So now, you should satisfy this restriction also, and your theta is getting maximized at x bar. So now answer will be what? Theta will be x bar when x is greater than x order 1. When this restriction is satisfied, when restriction in x bar is coming less than x order 1, then x order 1 will be the answer. So, this is bit tricky, for this, this is called as restricted MLE also. This is called as restricted MLE case also. We call this type as restricted MLE. This concept comes, like before, I'm going to teach a lot of question on this. So you will get used to it. So till now, what we have learned, we have learned basically first thing, we will find L, we will find log L, we will differentiate, and we will get the value for MLE. Second type, where, after differentiating log L, we won't be able to find any answer. So in that case, we will be trying to maximize L. So, basically the answer will be either it will be maximum, 85-90% cases, it will be order statistics will be the answer, x order 1, x order n, and basically any interval depending on both x order 1 and x order n. So that sort of answer will be there. So now for restricted MLE, we are going to solve like this case, especially this case, I am going to cover in detail. So don't worry about it. If you understood that, then it's okay. If you don't understood, don't worry. We are going to solve 4 or 5 questions on this. Then you will better understand this. And just type 1 problems and type 2 problems.
Hello, sir. Just
Yeah, go ahead.
So I'm just wondering. Just scroll it up. Just slide. Scroll it up. Scroll it up means just one. So here this xn, actually x order n, is actually maximize the likelihood function. That's why you are taking research.
No. See, what is order statistic? Order is basically, suppose x1, x2, xn is a random sample. So, observed random sample. So when you arrange in ascending order, so x order 1 will be the least value among all x1, x2, xn, and x order n will be the maximum value among x1, x2, xn. Yeah. Okay.
Yeah. So that's why so I'm saying that's why xn for the value of theta equals to x order n, this likelihood function is maximized.
No, this is going to depend entirely on the question. See here in this case, your theta should be less than x order 1. Okay. Because all xi should be greater than theta. What does this mean? This means that if all xi's are greater than theta, then minimum of xi will also be greater than theta.
Yeah.
Are you getting?
So,
the nearest to the theta is x order 1. So that's why x order 1, and this is just an assumption. You can look into this example. Xi greater than theta. I properly solved it. Then I got maximize L when theta should be x order 1. Theta should be maximum. The maximum value of x order theta is x order 1. So that's why x order 1 was the MLE. And this is just the assumption case, where I took,
Got it.
see, whenever xi should be greater than theta, then maximum time if log L, after differentiating log L with respect to theta, we are not getting any answer, x order 1 will be the MLE. And suppose xi is less than theta. Now xi is less than theta, another case. So this will be this way: x order 1, x order 2, x order n. This is going to be less than theta. Okay. Or for xi greater than theta, x order 1 less than x order 2 less than x order 3 less than x order n. But theta will be on this side and theta will be on this side. So in this case, x order n will be MLE. In this case, x order 1 will be MLE. Okay.
Yeah.
So
Thank
now, moving on to next question. This is a very good question. So f of x is equal to 1. To 1, your theta minus half xi, theta plus half x1, x2, x. This is another question. Okay. x2, xn, xn are observed sample. Now we have to find MLE of theta. Now in this case also you can see that in f of xi there is no theta. So in likelihood function also there won't be any theta. In log L also there won't be any theta. So you all find log L, you all differentiate log L with respect to theta, okay, and put it equal to 0. You will theta won't be having any value. Okay, so I'm again writing that question. Find L in this case, it will be 1 raised to n. Log L in this case, n log 1. Del log L upon del theta equal to 0. Theta won't be having any value. As there is won't be having any value. Why? Because theta is not present in the expression. So how can we differentiate? And we can expect that for any theta we will get any maximum likelihood. So in this case, what we are going to do? In this case, we just have to see this restriction. What is the range? Theta minus half, x order 1, x order 2, x order n, theta plus half. I have written this way. This is xi, theta plus half. Okay, this was given. So this is order statistics. Again, this will be always constant. X order 1 will be less than x order 2, x order n will be greater 1. So this will this way, we can write. Okay. So now some of you must be thinking that how we are doing this, but we can write this. This comes under the order statistics portion. So after studying this, you will get comfortable in this. See, this is an inference chapter. This is the last chapter of mathematical statistics. So there must be, you'll finding it a bit difficult to understand, all this concept observed order statistics and PDF and all. But when we do inference, after studying entire mathematical stats, we are going to do inference. So that will become easy for you. Now theta minus half, this way. So now there is theta minus half x order 1. First equation we are getting based on theta, and theta plus half greater than x order n. Second equation. So we can write theta should be less than x order 1 plus half from first equation. And theta should be greater than x order n minus half from second equation. So, combining both things, what we can write, theta should belongs to x order n minus half, comma x order 1 plus half. So, for any value lying between in this interval, you are going to maximize theta. You are going to maximize L theta. Why we can maximize? Because in L theta, there is no theta. So, whatever value you are taking between these two, L theta will be maximum. Why only between these two? Because there is some restriction here. So, that restriction we have to consider. Okay. So, any value lying between this two, this interval will be MLE. Now, I have a question. 4 times x order 1 plus 2 times x order n plus 1 upon 6. It is MLE or not MLE? So what you have to check is this value lies in this interval or not? So somebody, like, does this point 4x order 1 plus 2x order n plus 1 upon 6, this lies in this interval or not? You have to check this. Okay. So somebody of you right answer, like option should, like answer is, if for option 1 is MLE, option 2 is not MLE. Okay. So those who want to attempt it, write down. Okay. How x order n minus half is smaller quantity than x order 1 plus half? You tell me how x order, like, how it's, if x order n minus half is not a smaller quantity than x order 1 plus half, then, we won't be able to find single value of theta. And, in that case, this PDF won't exist. Are you getting, Tirtha? Hello, Tirtha, are you getting what I'm saying? Please unmute your audio and, please, like.
No, didn't get it.
Yeah, are you getting?
I didn't get. I am not getting that how x order n minus half is a smaller quantity than x. You have written the range as x order n minus half as the minimum value and x order 1 plus half as the maximum value.
So see, x order n should be greater than theta plus half. Is it okay until here?
Yes.
Now, first equation is what? X order 1 should be greater than theta minus half. First equation.
Yes.
And second equation is x order n should be greater than theta plus half. Okay.
Yes.
Now what I have got is theta should be less than x order 1 plus half, and theta should be greater than x order n minus half. Okay.
Yes.
Suppose what you are saying.
Oh, I got
X.
it. I got it.
You got it? Okay.
Got it.
So,
So,
sir, what?
Yeah. Hello.
Should I continue? Okay.
Yeah, sure.
Sir, this data is coming from uniform distribution, right?
Yes. It's
So
coming
then-
from uniform.
I think there in above inequality. So I think x order n less than equals to theta plus half.
Yeah. It is right.
Thank you.
Okay, so you have to check this, see, so, basically see anything that lies in this interval, from 1 we are going theta should be less than x order 1 plus half, and from 2 we are getting x order n minus theta should be greater than x order n minus half. So, the interval is this thing. Now the question is, if 4x order 1 plus 2x order n upon 1 upon 6 is a 6 belongs to this interval or not. If it belongs to this interval, then it will be also an MLE. If from this question we can say that MLE is not always unique. There is a property of maximum likelihood estimation that it cannot be it cannot be always unique. It can be unique, it can't be unique. In this case, we can see that there is a range of value for theta. Okay. So for this, you should know one property. 0 alpha, if alpha is lying from 0 to 1, then alpha A plus 1 minus alpha b will be lying between A to B. Okay. So here, we know some interval. Interval is what? X order n minus half to x order 1 plus half. And we know that ki theta belongs to this range. Now we want to check that ki 4 times x order 1 plus 2 times x order n plus 1 upon 6 belongs to this interval or not. So see, this is 2 by 6, this is already given. This is given. This expression is given. Ki whether this expression belongs to that interval or not. This is the question. Question is that ki whether this expression belongs to this interval or not. So how we can check? See, we can say that this is A, this quantity, and this quantity is B. So take alpha equal to 2 by 6. Why 2 by 6? Because we want to find for this thing. So x order n coefficient will be equal to, should be 2 by 6. So 2 by 6 times x order n minus half plus 1 minus 2 by 6, 1 minus alpha, x order 1 plus half. This is going to belongs to same interval by this property. By this property. So it will be coming as 2 by 6 x order n plus 4 by 6 x order 1 plus 4 by 12 minus 2 by 12. So it will be 2 by 2 x order n plus 4 x order n plus 1 upon 6. Exactly same expression. So that's why we can say that this is MLE. See, it is not a very easy question. This has, this comes in exam. So this is a bit tricky question. So again, I'm repeating it. Question was that ki fx is equal to 1. So differentiating log L, we were not able to find any value of theta. Then we considered this restriction, theta minus half to theta plus half. Basically xi is what? Xi is uniform distribution, which is lying from theta minus half to theta plus half. So I wrote this restriction. Then I got two equations. First equation is this thing, and second one is this thing. For theta. So from here I got theta should be less than x order 1 plus half. Theta should be greater than xn minus half. So we are not getting it at any single value. We are getting interval of value. So I know that any point which is lying between these two, any point which is lying in this interval will be MLE. I've already written that any point lying in this interval. So now the question was that this is MLE or not. So basically we have to check that this point is lying between this interval or it is outside the interval. So how to check? I use this property. What property I used? Alpha if alpha is lying from 0 to 1, alpha a plus 1 minus alpha we will be lying between a to b. So a to b is an interval. So here I took this interval a to b. I took value of alpha as 2 by 6. Why 2 by 6? Because the coefficient of x order n is 2 by 6. So this way I have done. So those who understood, please type yes in the chat box. Those who are not getting, please type no in the chat box. See, we cannot, Tirtha, we cannot do it in every case, there need to be, see, already, there are infinite number of families. Why? Because theta can take values from range of values. Anything that is lying between x order n plus half to x order 1, sorry, x order n minus half to x order 1 plus half is a MLE. Why 2 by 6 and 4 by 6? 2 by 6 and 4 by 6. Why? Because see, I have already given one expression. That expression was ki 4 by 6 times x order 1 plus 2 by 6 times x order n plus 1 by 6. So basically, you have to see that interval as a comma b. Please, HM, please unmute your audio. HM. Yeah. See. So, I already wrote this property. Ki alpha is lying from 0 to 1. Then alpha a plus 1 minus alpha b will be lying between a to b. Correct. Is it okay until here?
Yeah.
Then, we have got one interval. X order n minus half, x order 1 plus half. Take a as x order n minus half and take b as x order 1 plus half. Is it okay? Now, I want to check for this particular expression. I am already given. So, you know, there is 2 by 6 here. The coefficient of x order n is 2 by 6 here. So you tell me, what is coefficient of A? Coefficient of A is 2 by 6 now.
Oh, okay, got it.
So, you know, then, you know, I generally alpha A
I-
plus 1 minus alpha B.
Understood.
Okay. Suppose, so, you know, for today, you know, I think that is like, okay, you know, you all must have understood how I teach and all. So I don't think, you know, I need, like, you know, I solved tricky questions also. There are more tricky questions that I need, you know, there is one topic restricted MLE, you know, but I think, you know, that, you know, see, if I'll teach much thing, you know, some people confuse that, you know, it becomes quite hectic for this. You know, see, for MLE, I take 2 lectures of 3 hours. So, you know, whatever I have taught today, I will be, you know, generally finishing this much in 3 hours. I will be taking 3 hours time, one full lecture time. So there might be, you know, I was bit fast, you know, there must be something, as it is a demo class, so I have to solve a lot number of questions. I cannot give you much question as homework, you know. When I am teaching, you know, I will be focusing on this type of question, you know, the question which is tough more, and the easy questions like, you know, normal, Poisson, binomial, exponential, gamma, beta, you know, the question which are easy, I will be giving you as a homework. I will solve 1 or 2, and, you know, the same type of question I will be giving you as a homework. Okay. So those who have any doubt, you know, those who have any doubt, any question, you know, they can type that in chat box. And, you know, for question solving, for teaching, I'm done until here. So anybody, you know, like regarding notes, regarding anything, you know, regarding syllabus, anything you can ask me. You know, respond in chat box. If you don't have question, you know, you can leave. So now do one thing, you know, please, give me some feedback, you know, like before leaving, you know, please provide feedback whether I like you found it well, or is there anything that I can improve. You can write that in chat box publicly. There is no problem in that. You know, please write in chat box whether, sir, till then will we have access to your class when we enroll? Yeah, till when you will be having access, you know, to me, like, you know, to class, you know, it will be my plan is to finish portion by 31st March, and then, you know, you will get a break of 15 days until 15 April. Then, you know, from 15 April we will be having doubt sessions and mock test paper until the next RBI or ISS exam, whichever is, you know, being happening, you know, later one, like, you know, which is going to be, and will we cover the theory as well before jumping on to question? Yeah. You know, for like MLE, you know, I think, you know, I covered theoretical part, you know, in MLE, you know, after solving question, you know, we will be doing properties of MLE, asymptotic distribution of MLE, this type of thing we are going to do. So, you know, why I solved question, because, you know, you should know that, see, if you are understanding how I am solving question, then you will understand my theory part as well. So this was the most difficult part to explain and most difficult part to understand. So that's why I taught question. So theory will be explained. By when GATE syllabus will be finished by November. For GATE, you know, I'm not going to cover mathematics part. So, you know, you should know that. Why not mathematics part? Because, you know, in previous years also we have not covered, and we have got quite great result. And, you know, in GATE you won't be able to attempt all the questions. The questions are tricky, questions are time consuming, so you will be able to solve limited number of questions, but, you know, your accuracy should be good. So, you know, with only stats part, you know, mathematics part is very less. So I don't cover that. Why when GATE syllabus will be, any reference book we need to have? Yeah, for mathematical statistics you should be having the latest edition of S.C. Gupta, V.K. Kapoor. Okay, and in PDF form we will be having Hogan-Craig, Kessler-Berger, V.K. Rohatgi. Okay, if you can buy V.K. Rohatgi, please buy both books. V.K. Rohatgi buy, and buy S.C. Gupta, V.K. Kapoor's latest edition. You know, see, I will be giving you homework from S.C. Gupta, V.K. Kapoor for you to do at home, and I will be solving question in the class from Kessler-Berger, Hogan-Craig, and V.K. Rohatgi. Will homework question also? Yes, homework question will be discussed. You know, you will be doing homework, you know, 5 days a week, like Monday, Tuesday, Wednesday, Thursday, Friday. And on Saturday, you know, before the class, we will be discussing problems. We will be discussing continuously problem on the WhatsApp group of the class. Yeah, every class will be on this Zoom. Yes. Can you refer a book non-parametric? Yeah, please, please see my group. I have referred something there. I don't remember the name of the book. Complete list of book is given. Regarding free structure, sorry, you have to pay it, in one time. After like this is the last demo class. So now you have to, like, if you want to enroll, you have to pay the fees. So please, please everybody, please provide feedback. Okay, how you found this lecture and what can I improve? Especially like it was good and all. Don't try to write, what I can improve. When are the classes officially starting? See, from Monday I will be start sending assignments and tasks and all, and from Saturday classes is going to start. The last two, no, there is only one demo class. This is same as this one. The MLE chapter only taught, and from Saturday I'm going to start teaching probability and then random variable, and then complete mathematical statistics will be finished as first topic. That's how we are going to proceed. So classes will be officially starting. Yeah, I answered that. For theory, theory notes will be provided. Notes will be provided, in handwritten form. Whatever I am going to, write that way. Today's class feeling good. Then Friday. Yeah, somebody told me that I was going fast, on Friday, so I reduced my speed.